When it comes to the oscillation, uh, the first thing which I will say we will understand is this: a very important property with respect to the phase difference. Phase difference is something which you should be able to calculate whenever there are one or two wave which has been given to you. Okay, there are two formulas for phase difference which I say that one should remember. Phase difference is something, like if you have two waves given to you like this, one wave which is traveling from the mean position, the other wave is having some different mean position, and we simply say that okay, what exactly is the phase difference between these two waves. Now on the x-axis, depending on whether it has been given position or it has been given time, you can relate the phase difference formula as, suppose if you know that it is a position graph, so you will say 2 pi by lambda into delta x is basically the phase difference formula. So the two points, the difference between the 2 points, delta x, you can write in terms of wavelength, like whether it is lambda by 2, lambda by 4, lambda 3 by lambda 3 by 2 lambda, whatever it is. The moment you write in terms of lambda, then what will happen? Lambda will get cancelled and you will get the value in terms of pi.
Okay.
If the value being given in terms of the time difference between the 2 points, okay. By the way, I should draw both the graph over here so that you can see the second graph which I plot, let's say like this. Okay. So when I'm saying position difference, understand the position difference which I'm talking about is this point. Like when the green one is the mean position, white one is the mean position, this is delta x. Similar way, you can also do if it is a time graph on x-axis, 2 pi by capital T into delta t. Got it? So these are the two formula which will help you to get the value of phase difference, whether you calculate from delta x or you calculate from delta t. It is simply your choice. Got it?
Yeah.
Okay. Now when we talk about this oscillation, first of all you should know that the conditions which we have, by which we say that a body is moving in a simple harmonic motion. Do you know any condition? First is very basic. Whenever you talk about oscillatory body, it should be periodic. Okay, so means your oscillatory body should be a periodic body. Second thing you can say that, sorry,
to and fro motion.
To and fro motion is also I can write. There should be a to and fro motion, and that is how
acceleration is directly proportional to negative of displacement,
which is very important. Okay, but before that I will write there should be a restoring force. Okay, towards the mean position. So there will always be a restoring force acting towards the mean position. And the last one which you said is absolutely correct, that your value of acceleration should be directly proportional to negative of displacement. Okay, this is one important condition mathematically which we can write anywhere wherever you have to relate, like whether it's a oscillatory body or not. Okay, then we talk about how exactly a relation for position time can be written for a body which is moving in an oscillatory motion. So for that we take help of a uniform circular motion. We simply say that one complete circle represent a one complete wave like this. So if you take any particular point on the wave, you can show it on the circle, and this position where the particle is, if you wanted to write, you can simply do what? You can split this component on x-axis. you can split this component on y-axis, and you can say that if I write sine theta, it is opposite by hypotenuse. Now look here, when I say hypotenuse, the radius of the circle is nothing, it is going to be equal to the amplitude of the wave.
Yeah.
And that is the reason instead of r, I will prefer to write it as a. So I'm going to write this equation as y over a. So y can be written as a sine theta. So y is nothing, it is a position on the y-axis. A is your maximum displacement, or you can say it is an amplitude, sine theta. Make sure particle is moving with some certain speed, omega. So the value of theta can also be written as omega t. So I'm writing in terms of y, but even if somebody wanted to write in terms of x, you can even write that cos theta is equal to adjacent over hypotenuse, and x is equal to a cos theta. That is also perfectly fine.
Okay.
So studying this particular oscillatory motion on x-axis and y-axis is completely your choice, or the choice of an examiner where he wanted to give you. But if I have to write an equation in terms of position, which is y, it can be written as y is equal to a sine omega t.
T.
So y you have as a position, a is basically the maximum position, and this value of small t represent the time. So that is the reason I've written on the top position time relation it is. So at any
Okay.
given point of time, you should be able to calculate the position of a particle on the circle or on the wave. Got it?
Oh,
Okay.
yeah.
So this is my first formula. For second formula, what I will do, I'll find a velocity time relation. When you take this value of y, a sine omega t, and if you differentiate it with respect to time, you will notice that the value dy by dt will make it velocity, and d by dt of this term a sine omega t, when you do, look here, a is a constant, sine omega t is nothing, it is cos omega t, and this function you need to differentiate again. So the value looks like a omega cos omega t. This is your velocity time equation.
Okay.
Got it? Sometimes we also prefer to write it in a different way. So if you use an identity where sine square theta plus cos square theta is equal to 1, you can even replace the value of cos theta as 1 minus sine square theta, take a root on the other side. If you substitute this value of cos theta here in this equation, a omega cos theta is what? 1 minus sine
Sine
square
square.
theta. If you take the value of a inside, it is a square minus a square sine square theta. You already know that a sine theta is nothing, it is position. So if you wanted to write this equation as omega under root a square minus y square, it's perfectly all right. Got it? Both the cases, both the formula you need to remember. So any of the formula which you feel like is appropriate to use to get the value of v, just go for it. But I would suggest this formula is having more significance compared to the other.
Alright.
Okay?
Yeah.
Now we have position time, velocity time. So I hope you can understand where we are going. Now we will go for acceleration time relation. In acceleration time relation, what do you think what you will do? The above which we have written a omega cos omega t, if I again differentiate it with respect to time, now look here, dv by dt will give you a, d by dt, this is a omega cos omega t, this is how it will look like. Now I'm saying this is a omega is constant. Any idea what is the differentiation of cos omega t?
Negative sign.
negative sine omega t, and then again this have to differentiate the function. It is omega. The value will look like minus a omega square sine omega t. Now look here. Again, if I replace a sine omega t by y,
So negative y.
wonderful. So you can say that the very beginning, the condition which I have written, it is proved. But again, this formula for acceleration is very important. So first of all, you should be very clear with these formula for position time, velocity time, acceleration time. If I have to show you the graph for these three, let's say this is position. So position time graph, velocity time graph, and then acceleration time graph. Position time graph we have written it is a sine theta. So wherever the value of sine 0, 90 and 180, this is the sine graph. Velocity time graph, what you have written? Cos.
A omega.
Cos.
Okay,
So
cos.
basically this value of maximum amplitude, you can say it is a and it is minus a over here. Next graph you can say the value will be a omega. This is minus a omega. This is for velocity time, and velocity time graph is a cos graph, so value will look like this. And the last one is acceleration one. So value is here a omega square minus a omega square. It's a sine graph, but due to the negative sign, make sure the first graph and the third graph should be out of phase. You understand when I say out of phase?
Yeah.
That means when this is crest, this one is trough. And the angle between the two waves which are out of phase, what we say? The angle should be?
90?
No, pi. Whenever the two waves are having a phase difference of pi, you will say they are out of phase. Okay? Remember that.